Hey YouTube, it's Patrick from the Babylon.js team. Welcome back to the channel. Today what I want to talk about is one more video on motion graphics. We've done a couple of videos on techniques with motion graphics in Babylon.js recently, and I have one more technique I want to show you. It's one of the favorites that I have. I use this all the time. It's called taking Cartesian coordinates and converting them to polar coordinates. And it sounds like a mouthful, but it really isn't that bad. And what I use it for are things like this. So what you see here is something you've probably seen in AAA games, loading screens, UI, sci-fi UI in movies or TV, and it's this very simple circular graphic. And what I want to do with this is, rather than having to worry about geometry being super tessellated to make it super round, or textures, instead I said no geometry. These are just quads. And I have no textures, so this is all done in the shader. And we do have some separation in these quads. So there's 5 quads here. Each one has the same shader on it. And so we're able to create a bunch of different looks with the same shader, which is really cool. Makes it very versatile. You can create this entire look just out of the one shader and a few quads. So super exciting. Let's jump right into how we made it. And so what I want to do here is, let me get out of full screen, and we're going to jump into the Node Material Editor. And you'll notice I have the preview window popped out, which is a really cool function we added right around our last release, so that you can zoom in and see what's going on with your graphic. So this is what you would see when you first open up the Node Material Editor as default. And we really don't need to worry about our vertex. So what I'm going to do here is hold down Shift and drag a frame around this so that I can move it off to the side. And I'm even going to collapse it so that we don't even have to look at it. It's there, we still use it, but it's not necessarily to get any of the world space or vertex operations that we would have in the vertex shader. So we just want the fragment output, and I don't need our color for. We want to do polar coordinates. So to do polar coordinates, we need to start with a couple of gradients. And the easiest way to start with gradients is to just use the gradients that are already in UV space. So I'm going to come down here to Mesh and grab UV. And you see the UV is a vector 2, and I cannot put a vector 2 into the fragment out so that we can see what's going on. So I do have to split it. So let me grab a vector splitter here and wire up our UV. And then we have a cool function, which I'm sure you've seen, where you can take a single float and drop it on RGB, and it will put that same float in all 3 RGB. So you can see exactly what's going on. So you can see X is 0 to 1, Y is 0 to 1, going the opposite way. And so we're going to use those 2 gradients to convert from this rectangular gradient into a circular gradient, and you'll see why in just a second. So polar coordinates has an X channel and a Y channel, and both of them are different. One looks like a gradient, a circular gradient, and the other one looks like a gradient in a circle, so kind of like a clock face. And so we're going to do the Y coordinate, or the Y channel, first, because it's the easiest. The first thing we need to do is convert. Whoops. We don't want a frame here. I want to just grab these and move these over. The first thing we need to do is convert from 0 to 1 to -1 to 1. And you could just use the remap node. I'm going to show you a separate way to do that. And so what we're going to do is, since we have 0 in the range, when we use a remap node, there's going to be either an add by 0 or a multiply by 0. And so we don't really need all of the extra operations that are being done in the remap node. So a shortcut for that, and a very cheap shortcut for that, is to do a multiply and a subtract on both of them. So we need 2 multiplies and 2 subtracts. And so what we're going to do here is we're going to multiply each channel by 2. So we'll start with our X on that one and our Y on this one. And then I'll shortcut drag out here to get a float. And we'll call this 2, and then push this in over here. And then we're going to take the product there, and we are going to subtract 1. And so that is the fastest, easiest way to go from 0 to 1 to -1 to 1. So now, the other thing I want to do is, these are right now, because they're floats, we can change them. They're using a uniform in our shader. We don't want that because they're never going to change. So I like to make these constants so they don't take up one of our available uniforms in our shader. And so they're just there and don't ever have to be modified. So great. So now the easiest way to get to the circular gradient that we want in the Y channel is to take a length node. So if we come down here to vector math, we get a length node, but you'll notice it only takes a single input. There is no way to put a 2-channel in there unless we combine our 2 channels back in a vector merger. So let me grab a vector merger and bring it in here, slide these over. We'll drop this in X and this one in Y, and then take our vector 2 out. And then I can come over here and we can see what we got. Great. So we've got exactly what we want, 0 to 1 gradient. And let me show you really quickly how I use that to make these circles. So the easiest way to do this is with a step node. I use a smooth step node so that we don't have any pixelation in the circle. So if I say smooth step and then I drop this in, and then I will grab 2 values here, 2 floats. And what it's saying is if it is over the minimum value, it starts going from black to white based on how far apart the minimum and maximum value is, edge 0 and edge 1. And then we can, let me just wire this in and we can talk it through. So right now it's all going to be white because our edge 0 and edge 1 are both 0. And so if I start, let's make our edge 1, how about 0.6? And so you see a gradient again. And then I'm going to take this guy and I'm going to make this guy 0.5. So you can see we have a 0.05 difference between the min and the max. And so that's where the gradient lies. And so that gives us a nice fall off, a nice alias to the edge. And then if I get closer, so let's say, how about 0.59, you can see we get a really crisp edge, but it's still aliased. So we don't actually have any pixelation along the roundness. And so that's great. The other thing I like to do here is rather than having to set a minimum and a maximum on the smooth step, I like to add 2 floats together. So if I change one, the other one changes by default. So let me add that in really quickly too. So I'm going to add, and we're going to add our min and our max, and then drop it into the max. And then so this one now has to be 0.01, and that gives us back to the look we had before. So let's call this one diameter, and let's call this one alias. And so now I'm going to take our diameter, I'm going to make it a slider, max 0 to 1. So now I can actually slide this up and down, and you can see it's changing. And we also keep the aliasing from the addition that we did for edge 1, which is really cool. So and now if I wanted to, I can make these visible in the inspector. And now I can grab them in the inspector and make changes to them. I can animate them. I can do anything I want. So that's a really cool way to make a circle. But then how do I make the line? So the next thing we would do is I'm going to take another smooth step, and I'm going to do the same thing. I'm going to take another add node. So let's copy and paste one of those. And I'm going to take one of these guys and copy and paste it twice. So now I have a diameter. I'm going to call this inner diameter. And then we'll also call this one inner alias. And same thing, we're going to add the inner diameter to the inner alias. we're going to add the inner diameter as edge 0 and that as edge 1. And we still want our length node as our value. And so now what we see is that, which is great. So we are going to, oh, this one didn't update its name. So let me hit enter there. If that ever happens, make sure you go back and hit enter on the name field and it'll update. And because they're both 0.63, we don't want that. So this one, I'm just going to make that 0, 1 again. So now we have the same thing. So now what I'm going to do is I'm going to, let's see, the best way to do this one is we're going to make it a little bit smaller. And I'm going to 1 minus the, down here, we've got a 1 minus the inner diameter. So that will give us a white square in a black field. And this one gives us a black circle in a white field. And so now if I add the two of these together, you'll see exactly what I'm going for here, which is we get the difference. And there's our circle. So now I have control over my inner radius and my outer radius. And you can see where we also might want to say, okay, well, I just want a thickness value. So then we take our diameter, we add our thickness, we add our inner alias. So we can really kind of stack all those things up and make it driven by just one value, which is great. And that is exactly the basis for everything that we did. So now the other part of the polar coordinate, which is a little bit more complicated, is we need this circular gradient that looks like a kind of a clock face. So I'm going to take an arctangent 2, and we need the arctangent 2 so that we can have two inputs. And what I'm going to do is I'm going to invert these just because of the way I want to create this one. I want y and x, y and x here, and x and y. And then I'm going to divide these by pi. So if I bring this over here, we just want 3.14. And then let's see what we got. This should give us our gradient, which we want, which is great. This is the exact shape that we want. But you'll notice there's a lot of black here, and that's because this is still -1 to 1. So here is -1, goes to 0 here, and then back to 1 there. So we also need to remap this from -1 to 1 to 0 to 1. And again, there's a shortcut for that. So we just need a multiply and an add. And I'm going to multiply this by 0.5. And then we're going to take that and add 0.5 to it. And that will remap from -1 to 1 back to 0 to 1. And then you can see we've got 0 here all the way up to 1 there, which is great. So then you can see where I'm going here. We would do the same thing where I might do a smooth step to give myself control over where on this gradient that we are, and then multiply that with my ring. And then that way I can start knocking out parts of the ring. And that's how we can get that animation that allows you to kind of like scroll around. So before we get too far into that, I do want to show you one other thing. And that's what polar coordinates usually is used for, and that is remapping our texture space. So let me grab these guys, and I'm just going to move these out of the way. And we've got, I'm also going to have to do a 1 minus on this Y channel for this to work correctly. So now we would have this in our X channel and this in our Y channel. And then what this is going to do is remap a square texture into a circular texture. And the easiest way for us to show that is, let me jump into, I need an input node for texture. And I'm just going to upload this UV map that I use. It's just a a very simple grid that I use when I'm UVing to make sure that I have equal textile density around a mesh as well as minimal distortion. But this is also a really good way to show what happens when you use a polar coordinate. So right now it's using the UVs that we have in the scene already. But if I were to take this and replace the UVs with, let me take a vector merger here and give us another UV with X and Y and drop that in for our UVs, you can see what happens is we remap texture space into a circle. So this is another way we would potentially use polar coordinates, which is also very interesting. But let me jump into you've seen kind of the basis of how I created the shader. Rather than going through everything that we did in that shader, I'm going to jump back into the project so that you can actually see what we did with the shader here. So let me open the node material editor from this guy. And you can see here's our polar coordinates. I did a rotation on X so that we could rotate that, that circular gradient around. And that way, if we have to change where the dashed lines are sitting or aligning them, we can do that. We also have the mask part of it, which we talked about, taking a smooth step node and chopping off that circular gradient again so that we can multiply it with the line and get rid of portions of it. We've got the ring, which we went through already. And then we have this dash portion. And the dash portion basically is just taking that circular gradient and putting a sine function on it. And the sine function makes it go black, white, black, white, black, white. And then that way we can take that and multiply that with our line to knock out certain sections. And we end up with a dashed line. So you can see when we come all the way to the end here, we just have a single color for the ring color, and then everything else goes into alpha, which is great. So the best way to show you kind of the power of what we can do with this is just to come back, and I'm going to open this up a little bit further, and you can see I've created a few groups in our output nodes, and so these are the three sections. Let me pull this up that of controls that we have, and so I just happen to have ring map, which is let's just make this a little bit easier, and I'm going to get rid of that one and that one and this one and this one. So now we just have the ring map. So you can see we have control over our radius. So we can make it whatever radius that we want. We have control over our color. We can change the stroke alias to make it blurrier or sharper. We can change our thickness on the line. So maybe I make it like that and it's a thicker line. I can even do things like, let's bring it down to 0 here and make it really thick. And we're going to say it is a 0.1. And so now we get this kind of, or actually let's make it even bigger. How about 0.4? So now we get this nice, almost pie kind of animation. And what I'm doing here in the interim as it goes from revealing to hiding is we're flipping the X channel of the polar coordinate. So it goes from 0 to 1 counterclockwise to 0 to 1 counterclockwise. And that's how we're getting the reveal to animate both that way. We can also, let me change this back up to a little bit bigger. And let's go down to, let's say 0.2. Sounds good. We can come up here and say it's dashed now. So now we have a dash line. We can change the number of dashes. Let's say 250. So now we've got a very high frequency dash line. We can change our dash gap and make it smaller. Let's go down to 4. Okay. So now we can change our dash gap and see, how much, how big or how small that we want our dash gap to be. And then we can change our alias, let's say 9 and it's bigger, or let's say 1 and it's smaller. So we have a lot of power in just using this simple technique. The playground you're seeing here we'll have in the comments below, so feel free to jump in. Most of it is setting up our animations. And so it does look like it's a lot of code, but it's not really that much code. Basically, we have to set up our animations. We have to grab all of our parameters from our 5 different planes that we've assigned cloned materials to, and then we're just manipulating all those parameters. So we do have a bunch of parameters for each material, and that's why this looks like it's a lot of code, but it's not really a lot of code at all. So feel free to jump in, play around with it. If you have questions, leave them in the comments below. If you like this content, we'd like to see more of this kind of thing. Let us know. Leave a like. If you don't like it, leave a dislike. We like to hear the feedback. We'd love to hear anything that you have ideas for the future or questions you have about this. And we hope that you're having fun with Babylon, and we will see you in the next one. Take care.